This is question number 2 from test 3, and we want to use elimination method to find the solution. So first of all, we are going to move 8x and 6y to the other side, and negative 6x and negative 4y to the other side. So we get 2x prime minus 8x plus y prime minus 6y is equal to e to the power negative t. And by the way, you can solve these systems of linear equations using any technique you want. So at this point, you have learned multiple techniques, but I think for this particular problem right now, what I'm going to use is the easiest. So then I am going to write the second equation as x prime plus 6x plus y prime plus 4y is equal to et. So you really have to be very organized here. Watch out for your sign. I always myself make mistakes here. Too many details to keep track of. So what I did was subtracted 8x from both sides, subtracted 6y from both sides to organize them this way. So these are gone, and then I paired up these two. I put them next to one another, and I put those next to one another. I did the same thing here, added 6x, added 4y, added 6x, and added 4y. These two together and these two together, okay? So that's what I have done. Okay. Next, I'm going to use the notation. Instead of x prime, I'm going to use dx. And for y prime, I'm going to use dy. So I have 2 dx minus 8x plus dy minus 6y is e minus t. And here I'm just going to again call x prime dx plus 6x plus dy plus 4y is equal to e to the power t. I'm going to take the factor dx from these two. I'm going to factor y from these two. So we get 2d minus 8x plus d minus 6y is equal to e negative t. And then again, d plus 6x plus d plus 4y equals to e to the power t. Then, to solve for x, we are going to create a determinant and apply Cramer's rule to solve for x. The coefficient of x is 2d minus 8. The coefficient of x is d plus 6. The coefficient of y is d minus 6. The coefficient of y is d plus 4. We form a determinant, and then we are going to put x equals to, then we create another determinant here. So we call this determinant d determinant, and we call this determinant d sub x, if you remember that from college algebra. So when we form this other determinant, I'm going to leave the y column alone, but I'm going to use these for the x column. We call this d sub x, we call this one d. And then we are going to put the y column, which is d minus 6, d plus 4, here. So let me get rid of these. And now to evaluate a determinant, we multiply this diagonal first. We go 2d minus 8 times d plus 4 minus d minus 6 times d plus 8 plus 6, I'm sorry. Then we multiply these two. And the same thing here, we multiply these two. We have d plus 4 times e minus t minus, then we multiply this diagonal, d minus 6 times e to the power t. So next, we are going to multiply, simplify 2d times d is 2d to the power 2. 2d times 4 is positive 8d, negative 8d, negative 32. Then we are going to multiply d minus 6 by d plus 6. This gives us d squared minus 36, the difference of two squares. Then negative gets distributed, we get negative d squared and positive 36x. Now, let's simplify further. We have 2d squared and minus d squared. They're like terms. We get d squared. These two cancel each other. Negative 32 plus 36 gives us positive 4x. So what does this here mean? So d times e minus t, we have to find derivative of this e to the minus t. 4 plus 4 times e minus t minus d derivative of et, and then negative times negative is positive 6 times et. So what is derivative of e to the power negative t? That's negative e to the power negative t plus 4e to negative t minus derivative of et is just et plus 6et. I'm going to simplify this side. We have d squared plus 4x is equal to, these are like terms, we get 3e to negative t. These two are like terms, we get positive 5e to the power t. Okay, so now in order for me to solve this, I'm going to write d squared plus 4 as r squared plus 4. That's what we have. We have d squared of x plus 4x. So we write the characteristic equation. We are trying to find a homogeneous solution. So we only solve r squared plus 4 by subtracting 4 from both sides. We get r squared is minus 4, or r is positive negative square root of both sides gives us 2i. So that tells us that our solution x, homogeneous solution, is equal to a cosine of 2t plus b sine of 2t. We could also find a particular solution by guessing that it is, let's call different letters, C1 e to the power negative 2 plus C2 e to the power positive 2. So what we are going to do with the particular solution is we are going to find the first and second derivative substituted here to find out our particular solution. We find x prime of p which is negative C1e minus t plus C2e to the power t, because derivative of e to the power t is e to the power t. We find the double prime, which is derivative of e to the negative t is negative e to the power negative t, which is going to be negative and negative makes this positive again. And now we are going to substitute them. So I substitute that here, and I substitute that for this one, because this one is t2x plus 4x, and we are going to substitute them. So I get C1e minus t plus C2e positive t plus 4 times x, this is x here, which is C1e negative 2 plus 4C2e to the power positive t. And then we set this equal to 3e to the negative t plus 5e to the positive t. We are going to collect like terms. That is going to give us 5C1e negative t, and then we have 5C2 e to the positive t is equal to 3e to the negative t plus 5e to the power positive t. Then we are going to set these two equal to each other. We get 5C1 e to the negative t is equal to 3e to the power negative t. And that gives us C1 is equal to 3/5. Next, we are going to go after these two. We are going to set these two equal to each other. And that tells us 5C2ET is equal to 5ET. We cancel each other. Divide both sides by 5. We get C2 is 1. So what is our particular solution look like? Our particular solution is going to be C1, which is 3/5 e to negative t plus 1 e to the power positive t. So x of t is both solution, this one and this one. So it's going to be a cosine of 2t plus b sine of 2t plus et plus 3/5 e to the power minus t. Now the last thing we want to do is also finding y. To find y, we have here we take this equation first. This one or this one. I think it's easier to take this one. We have x prime plus y prime minus 6 plus 6x plus 4y is equal to, and maybe move the last term over to, we have minus e to the power t. So I move everything to one side, set it equal to 0. Then, no, I should have done it differently. Let me just go back and get rid of that, get rid of that, get rid of these. So what we had was x prime plus y prime is equal to minus 6x minus 4y plus et. What I want to do is, since I want to solve for y and I want to use a substitution, I'm going to move everything to this side and move y to the other side. So I want to subtract x prime, subtract y prime from both sides. And not yet, because now I have what we're trying to do is we have the solution to x, we want to find the solution to y, but we have y prime and y, and in this first one we also have y prime and y. So let me write down that one as well. We have 2x prime plus y prime is equal to 8x plus 6y plus e to the power minus t. That's what we have. So what I want to do right now is eliminate y prime, and then I want to isolate y. So let's add the two equations, or rather subtract the two equations. So subtract. So this way y prime gets eliminated. So I have x prime minus 2x prime. That gives me negative x prime. I have y prime minus y prime. I get 0. They're gone. Then I have minus 6x minus 8x. That gives me minus 14x. Minus 4y. This becomes negative 6y. That becomes negative 10y. As I said, I'm subtracting this equation from the other. So this way, y primes get eliminated. And then I have negative ET and positive ET, so I just add them because they're not like terms. So this is what we have. Now I'm going to move x prime to this side. And I'm going to add a 10y to both sides. So what I have is 10y equals to x prime minus 14x plus e to the power t minus e to the power negative t. And that's what we have. And then lastly, I'm just going to divide both sides by 10. So let's do that and find y. To do that, I need x prime. So let's find x prime. X prime of t is equal to derivative of cosine is negative sine, derivative of angle 2t is positive 2. So we get negative 2a sine of 2t plus derivative of sine is cosine of 2t, derivative of the angle is 2, we get 2b cosine 2t. Derivative of et is et, derivative of negative 3/5 of e to the negative t is negative 3/5 of e to negative t. So that's our x prime. So let's substitute everything here. This x prime is, and I'm going to write this 1/10 over here. It makes the algebra easier. So I put minus 2a sine of 2t plus 2b cosine 2t plus et minus 3/5 of e to the power negative t. Then I have negative 14x, so I have to, this 1/10 is going to get multiplied by everything. So now I have to multiply negative 14 negative 14 by x, and I'm just going to write it here. So I get negative 14a cosine 2t, negative 14 b sine of 2t negative 14 e to the power t, and negative times negative is positive 14 times 3 over 5 e to the negative t. And then what else we have? We also have these two guys. We have positive e to the power t and negative e to the power negative t. And everything gets combined like terms, and at last we multiply by 1/10. So let's see what we have. For sine, we have negative 2a and negative 14b. And then we have sine of 2t, this one, and this one. And then for cosine, I'll put a plus sign. For cosine, we have 2b and negative 14a. And by the way, I think my lab math is using letters C1 and C2 instead of A and B. And then we have cosine 2t. So you should use C1, C2 as well. Then we have to add these guys, right? So I have for e to the positive t, e to the power positive t, I have one of them here. And I have another one here, so that makes it 2. And then I have negative 14. So that gives me negative 12, e to the power t. For negative e to the negative t, I have this one, and this one. So I have a 3/5. I have a 3/5 negative. I have a positive 14 times 3 over 5. And then we have a negative 1 for e to the power negative t. What I did here, because I see they both have a 3/5 common factor, I factored the negative 3/5 from both of them. So I get positive 1 plus 14. If I factor a negative 3/5 from this one, I get 1. If I factor a negative 3/5 from the other term, I get positive 14. 1 and 14 is 15. So I get a 15. 15 and 5 are reduced. I get 3. 3 times negative 3 is negative 9. And negative 9 and negative 1 gives me negative 10. And we're almost done. We just go ahead and divide everything by 10. So I'm just going to distribute the 10. This gets divided by 10. This gets divided by 10. This term gets divided by 10. And that term gets divided by 10. So our final answer for y of t is, do you see I have this 10 and this 2 and 14 get reduced? I get negative a negative 7b over 5 sine of 2t. This 2, 10, and this 14 are reduced. I get b minus 7a over 5 cosine of 2t. 10 and 12 are reduced. Both are divisible by 2. I get 6 over 5 e to the power t. 10 and 10 are reduced. I get e minus t. So that is the solution to y, and this is the solution to x.